Hi everybody, this is Surya Kausal sir from Naujiman Mission School Kasya. Today I am going to discuss one chapter of NCERT Physics Electricity. So guys, in this chapter I will cover electricity, types of electricity, electric charges, types of electric charges, electric field and electrostatic potential. So guys, let us start this chapter. Electricity. What do you mean by electricity? Simply, we can say that it is a form of energy. It is a form of energy. It is a form of energy which works on the principle of electric charges. Which works on the principle of electric charges. Okay, it is a form of energy which works on the principle of electric charges. So guys, what do you mean by electricity? It is a form of energy which works on the principle of electric charges. So guys, you have heard in class 9th there are many forms of energy, okay, such as kinetic energy, potential energy, heat energy, light energy, electrical energy, as so on. Okay, so this electrical energy is going to discuss in this chapter, electricity. Okay, so how many types of electricity? There are two types of electricity. Okay, there are two types of electricity. Electricity. First one is electrostatics. Electrostatics. Another one is electric current. Electric current. So guys, electrostatics. Statics means what? Statics means rest. And electro means electric charge. Electric charge. So on combination of these two words, we get it is a branch of physics. It is a branch of physics which deals with electric charges at rest. It is a branch of physics which deals with electric charges at rest. Okay. So what is electric current? What about electric current? Electric means electric charge and current means what? Motion. Okay. Then the rate of flow of charge is called electric current. Mathematically, we can write it I is equals to Q upon T. What do you mean by Q? This is flow of charge. Flow of charge with respect to time. Okay, time taken. So guys, you can say that the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. What is the SI unit of electric current? The SI unit of electric current is ampere. The SI unit of electric current is ampere. It is represented by A. Okay. Or you can say that Coulomb per second. Okay. Coulomb per second. Because the SI unit of charge is Coulomb and the SI unit of time is second. So according to this formula, we can write here Coulomb per second is also a SI unit of electric current. Okay. So guys, here one terms are repeated again and again. Electric charge. Electric charge. What is the importance of electric charge in this chapter? What is the importance of electric charge in this chapter? Guys, it's very important phenomena on which this chapter is dependent. Okay. So, electric charge is what? The property of electron and proton. It is the property of electron and proton due to which electric force arises. Okay. Electric charge is what? It is the property of electron and proton due to which electric force arises. Okay, guys, by convention, there are two types of electric charges. By convention, there are two types of electric charges. One is positive charge, another is negative charge. It is by convention because no one have seen that. Okay, so guys, we can say that by convention there are two types of charges. One is positive charge, another is negative charge, and these two charges form two terms. Okay, one is like charge, like charges, another is unlike charges, another is unlike charges. So guys, what do you mean by like charge? Like charge. Like charge means what? Like means same. Like means same. Sorry. Like means same. So same types of charges. Same types of charges are known as like charge. Same type means what? Positive positive or negative negative. Okay. So same types of charges are known as like charge. And unlike mean what? Different. Okay, so different type charges are known as unlike charges, such as positive negative, or you can say that negative positive. Okay, so there are two terms of charges, like charge and unlike charge. Like charge means same types of charges are known as like charge, and different type of charges are known as unlike charges. So guys, here like charges always repels to each other. Okay, like charges always repels to each other, means between like charges means positive charge always repel to each other, or negative charges also always repel to each other. Okay, so between like charges there will be force of repulsion. What is in the case of unlike charge? Unlike charges always attract to each other. Okay. Unlike charges always attract to each other. Attract mean what? In between unlike charges there is force of attraction. Okay. So there are two types of electric forces. Electric forces are two types. One is attractive, or you can say that another one is repulsive. Okay, so like charges always repel to each other and unlike charges always attract to each other. Why like charges repel to each other or unlike charges or attract to each other, I will discuss after some time. Okay, so what do you mean by electric field? Electric field. Electric field. See here, here is field. Field means area. Okay, field means what? Area. And electric means electric charge. Okay, it is an area around a electric charge. Okay, or you can say that the space around any electric charge in which another test charge can experience the attraction or repulsion. Okay, so let us suppose this is our source charge. Around this source charge there is a region in which if this Q0 charge enter, then there will be attractive or repulsive forces will act. Okay, if this test charge will be out of this region, then there will be neither attractive nor repulsive force. Okay, so only in this particular area the electrostatic force can be act on this charge or on this charge. Okay, I have told you that like charges repels to each other and unlike charges always attract with each other. What is the main reason behind it? I am going to discuss that. Here, in the case of positive charge, the electric field lines emit from the charge in outward direction. Okay. But in the case of negative charges, the electric field lines will be inward towards the charges. Okay. So here this electric field lines and this electric field lines, both electric field lines are in outward direction, so they will repel together. Okay, so they will repel together. Here also on negative charge, both electric field lines on this charge particle or on this charge particle. On both charges, the electric field lines are inward, so they will also repel together. Okay, but in the case of positive and negative charge, they will attract together, because from positive charge the electric field lines are going outward, but in the case of negative charge the electric field lines are inward, so they will attract together. These electric field lines do not form a closed loop. Okay, what do you mean by a closed loop? I am giving an example. In the case of a bar magnet, okay, or simply you can say that in the case of a magnet, the magnetic field lines emit from the north pole and comes to the south, but inside of the magnet the magnetic field line goes from south to north direction. So you are looking that the magnetic field line is forming a closed loop. See here, the magnetic field line is forming a closed loop, but in the case of electric field line, it is not forming a closed loop, because always the electric field lines emit from the positive charge and emerges on the negative. So it cannot form a closed loop, but magnetic field line can form a closed loop. One another thing I want to discuss in this chapter, quantization of electric charge. What do you mean by quantization of electric charge? The electric charge is the integral multiple of fundamental unit of charges. Okay, electric charge is the integral multiple of fundamental unit of charges. Okay, means what? It is the integral multiple. It cannot be in the form of fraction. Okay, where n can be equal to 1, 2, 3 as so on. Okay, so charge is the integral multiple of fundamental unit of charges. Okay, we are going to solve a numerical on this concept to calculate the total number of electrons present in 1 coulomb of charge. Okay, in 1 coulomb of charge. Here the value of charge is 1 coulomb. Okay, the value of charge is 1 coulomb, and as we know, on an electron the total charge will be equals to 1.6 into 10 to the power minus 19 coulomb approx. Okay, so as we know that n will be equals to q by e. Okay, what is the value of q? It is 1 coulomb, and the value of charge on electron is 1.6 into 10 to the power minus 19, which will be equals to 0.625 into 10 to the power 19, or you can say that 6.25 into 10 to the power 18. Okay, so the number of electron present in 1 coulomb of charge will be equals to the 6.25 into 10 to the power 18. So we can say that coulomb is a bigger quantity of the charge. Now there is a question, how electric current can flow in a conductor. As you know, there are 3 types of material: conductor, insulator, and a semiconductor. Okay, conductor, insulator, and a semiconductor. So guys, what do you mean by conductor? Conductor, इसके नेम में देखिए, conductor, conduct, which can conduct electricity. Okay, which can conduct electricity are called conductors. What do you mean by insulator? Insulator, those substances which can't conduct electricity because its conductivity is very low. Okay guys, so insulator is what? Those substances which cannot conduct electricity. What do you mean by semiconductor? It is the intermediate of conductor and semiconductor. Okay, it is the intermediate of conductor and sorry, it is the intermediate of conductor and insulator. Okay, so the question is what? How electric current can flow in a conductor? There are many free electrons are present in a conductor. Okay, there are many free electrons are present in a conductor, but in the case of insulator, only bound charges are present, not free electrons. Okay, and in the conductor, these electrons are moving here and there randomly. Okay, not in a particular direction. It moves in a zigzag path. When we applied some potential difference on it, let us connect it with a source of electricity, or you can say that with a battery. Okay, and a switch. When you switch on the circuit, then each and every electron will move in a particular direction towards the positive terminal of the battery. Okay, each and every electron will move towards the positive terminal of the battery. Why it is flowing in the positive terminal direction? What is the reason behind it? Because electrons are negatively charged particles, so the positive terminal will attract it. Okay, so each and every free electrons will move towards the positive terminal of the battery, and in the opposite direction of electron, electric current will flow. Okay, in the opposite direction of electron, electric current can flow. Electrostatic potential. Now electrostatic potential. What do you mean by electrostatic potential? When a unit positive charge, when a unit positive charge comes from infinity to a particular point, okay, this is point A, and let us suppose this Q0 charge is moving from infinity to point A. Okay, when a unit positive charge comes from infinity to a particular point, okay, then the total work done by the this charge, okay, then the total work done by this charge is known as electrostatic potential. So you can say that when a unit positive charge moves from infinity to a particular point, then their total work done will be known as electrostatic potential. Then what is electrostatic potential difference? What is electrostatic potential? I just clear one thing, that potential depends on the position. Okay, the potential depends on the position, or you can say that distance. Okay, if Q1 charge is placed here with respect to the origin, so its potential difference is V1. But if this Q1 charge moves from this point to point A to B, then this potential difference becomes V2. Okay, because our potential difference, or you can say that our potential depends on distance also, because V is equals to 1 upon 4 pi, or simply you can write K Q1 by R. Okay, so this potential is directly proportional to the charge but inversely proportional to the distance. So you can say that the difference between these 2 points potential is known as potential difference. Okay, it is represented by delta V, and delta V will be equals to V1 minus V2. Okay, or you can say that when a unit positive charge moves from a point to another, okay, when a unit positive charge moves from one point to another, then their work done is known as electrostatic potential difference, or simply you can write here V will be equals to work done per unit test charge. What is the SI unit of this potential difference? The SI unit of potential difference is volt. Okay, it is also represented by V. Okay, so the SI unit of potential difference is volt. There is a device which used to measure the potential difference in a circuit, which is called voltmeter. Voltmeter. And the device which used to measure electric current is called ammeter. Okay, A meter is a device which used to measure electric current in a circuit. So here I will be directly proportional to V. Mathematically we can say that I mean what? Electric current will be directly proportional to the applied potential, or we can write V will also directly proportional to I from this above equation. So V will be equals to R into I. When proportionality will be removed, then here will be a constant term called resistance. Okay, this constant term is known as resistance, where R is equals to resistance of the circuit. Okay, so from this formula we can write here R will be equals to V upon I. R will be equals to V upon I. Electric current flowing through the circuit will be inversely proportional to the resistance according to this formula. Mean what? If resistance will increase, then current will decrease. Okay. Or you can say that if resistance becomes half, then current becomes double. Okay. Means both are inversely proportional to each other, resistance and electric current. Okay. And this resistance depends on some following factors. Those factors I will discuss later. Okay, the SI unit of resistance is ohm. Okay, firstly we will do a numerical on this topic. Let us consider a wire having length L, and in this wire I amount of electric current is flowing. Okay, if we increase the length of this wire and it becomes 2L, then what will be the effect on this electric current? You will solve it. Okay, so I am going to discuss that resistance depends on four factors. First one is length of the conductor. So resistance will be directly proportional to the length of the conductor. Means if the length of conductor will increase, then resistance will also increase. If the length of conductor becomes half, then resistance will also becomes half. And if length becomes double, then resistance will also doubled. Second one is what? Resistance is inversely proportional to the area of cross section of the wire. If the wire becomes thicker, then resistance becomes less. Okay. What do you mean by area of cross section? In the case of cylinder, area. This is curved surface area, and this area is called area of cross section. Area of cross section. Okay. So resistance is directly proportional to the length of the conductor. It is inversely proportional to the area of conductor, and also the resistance depends on temperature. We can't say directly, okay, because in some cases it is also inversely. So it also depends on temperature, and fourth one is nature of material. Okay, so resistance depends on nature of material. So here you have seen resistance is directly proportional to the length of conductor. This is a hint to solve this question. Resistance of the wire is directly proportional to L, and also inversely proportional to A, means area of cross section. Let us suppose this is our first equation and this equation is second equation. Okay, on combination of these two equations we get on combination of above equations we get R will be directly proportional to the L by A. When proportionality will be removed, then here will be also a constant term called resistivity. Okay, called resistivity. So resistance will equals to rho L by A. This is called resistivity. Rho is what? It is a constant term called resistivity, or specific resistance. specific resistance. Why it is called specific resistance? Because it can be also called a resistance, but in a special case. What is that special case? Length, if length is unit, means it is 1 meter or 1 unit, and area of cross section is also 1 square unit, then the resistance will be equal to resistivity. Okay, so resistivity is also called specific resistance. So guys, this Ohm's law is very important chapter, part of this chapter. Okay, it is also very important for your board examination. Okay guys, आज के लिए इतना ही. Thank you. I will discuss the remaining part in next video.